Today I am going to talk to you about gears, design of gears. So this lecture is about the point of view of how to design a gear. So we are not going to study everything about gear. We are going to know the essential things for designing a gear. Okay, so you had already learned about gears in your previous semester, in your previous subjects. So in this semester we are going to design a gear, design different types of gears. So before going for the design, you should know what are the type of gears that you have to design, or what are the basic classification of gears. You have already studied various classification of gears based on the gear arrangement or the gear tooth profile, etc. In this semester you should know about various type of gears based on tooth profiles only, nothing more, no need to more complexity. The basic classification of gears is based on the gear tooth profile. So you are going to study about various type of gears based on gear tooth profile. So know about the basic classification, the different gears, and how to design each of them. You have to study each of the gears, how to design each gears you have to study. So in this video we will study about various type of gears and how they are classified, and basic things only, and then we will go for the design procedure for the first type. Okay, so before starting, I want to say that in this video we will go in Malayalam language, and for easy learning, due to the current scenario of the pandemic spreading all over the world, we don't have time. So we have to learn it quickly, and we have to learn it much easily with time saving. So I'm going to take this video lecture in Malayalam. So if you have any sort of language problem or any difficulty, mention that in the comment box, we shall fix it. Okay, so let's start. So different types of gears. So our topic today is gears. So first of all, different type of gears. Based on tooth profile, we can classify the gears as 4. Spur gear, helical gear, bevel gear, worm gear. These are the basic classification. We can classify more and more gears. We can enlarge the list by adding some more gears, herringbone gears, double helical gear, but it's not mentioned in the syllabus. That's why I am not mentioning that here. Let's skip those things. Those things are available in open sources. You can learn that, no problem. But for the current syllabus for Kerala University, for Kerala Technological University, we have to learn these 4 types of gears, theoretically as well as in design point of view. You can really just know. I will tell about what is the basic differences between each of these gears, or how they are classified. Okay, spur gear. Spur gear is used to transmit power on parallel shafts. Okay, I will draw a figure simply. As you know that a gear will not be drawn in a single, because for transmitting a power there we need at least 2 gears, minimum 2 gears we need. So we have 2 gears, one will be rotating in clockwise direction, another will be in anti-clockwise direction. Okay, among the one will be pinion and one will be gear. Those who have power will be the pinion, and those who receives power is gear. Okay, this is the basic idea about gear system. Okay, so spur and helical will be looking like this. Okay, let's draw the side view where the things will be changing. Suppose this is a spur gear. Okay, and this will be the shaft axis where the gears are fixed. Okay, suppose this is a spur gear. Okay, and suppose Okay, for a spur gear, the teeth of the gear should be parallel to the shaft axis. So we know that this is a shaft. Now this is a shaft. Then the teeth, the gear teeth should be parallel to the shaft axis. That means the teeth will be looking like this. And this is a spur gear. So the next comes the helical gear. The helical gear also, the shafts will be parallel, but the gear teeth will be inclined, non-parallel. That is, the gear teeth will be looking like this. So this is a helical gear. Okay, as we can see that for a spur gear and helical gear, the shafts will be parallel, and for a spur gear, the gear teeth will also be parallel. For a helical gear, the gear teeth will be inclined into the shaft axis. So for a spur gear, gear teeth will be parallel to the shaft axis. For a helical gear, gear teeth will be inclined into the shaft axis. Easy, simple. This is the basic difference between spur gear and helical gear. Let's go for the next one. Bevel gear. Bevel gear. How will a bevel gear appears? A bevel gear will look like this. And how will the power be transmitted? Let's look. So the shafts will be looking like this. The teeth will be of two types. This is a bevel gear. This is a bevel gear. And the fourth one, worm gear. This is a worm gear. Okay, and the worm wheel will be looking like this. This is how it looks like. This is how it looks like. This is called as worm, and this is called as worm wheel. Worm wheel. So this will have a tooth in this surface, and this will have a tooth in this surface, and it will transmit over like this. Okay, so here also the shaft is a non-parallel shaft. Here also a non-parallel shaft. Here is a parallel shaft. Here is a parallel shaft. These two are non-intersecting. This is intersecting. This is non-intersecting. This is a basic classification. That spur gear have parallel shafts in power transmission. They are non-intersecting. Helical gear also, they have parallel shaft in power transmission. They are also non-intersecting. But the teeth is inclined. Here the teeth is also parallel. For the case of bevel gear, we have intersecting gears. That means the shaft axis. If this is the shaft axis and this is the shaft axis, it will intersect at this point. This is the point of intersection. If this is the shaft axis, since they are parallel, they will not intersect. This is non-intersecting, this is also non-intersecting, but this is intersecting. Okay, this is also a non-parallel shaft. Worm gear is also a non-parallel shaft. Okay, so these four types of gears are there. This is a basic. Beyond classification, we have other type of gears also. Herringbone gears, double helical gears. Double helical means the same profile. One more will be there. That will be opposite profile. It's not mentioned in the syllabus. That's why I am not taking. I'm not talking about that. So these are the basic 4 classification of gears that you should study. Okay, these things are mentioned in the syllabus. Know the basic thing, and then how it differentiates from the other, how the tooth profiles, how the power transmission. This is parallel power transmission. This is parallel transmission. This is non-parallel power transmission. This is non-parallel power transmission. The teeth are straight. The teeth are inclined. The teeth can be either inclined or a different type of thing. You are studying about the parallel case. Okay. Similarly, we can draw like this also. And helical case also. Here also this is entirely different. Ohm and ohm wheel is entirely different than other type of gears. This is a non-parallel gear, non-intersecting gear. This is a intersecting gear. This is a parallel, non-intersecting. This is also parallel, non-intersecting. This is the basic difference between. One more thing I will tell you: the helical gear is used in power transmission. Spur is also used in power transmission, but helical gear is used more in automobiles because helical gears. You can see that for the same phase width, Spur gear is having less teeth length than this, because you can see that this is inclined. The teeth are going diagonally, so the diagonally this is having more length than this teeth. You can see this teeth is having more length than this teeth, so the teeth will be much longer in helical gear compared to Spur gear. So it can have more conductivity here, so it can withstand more load, it can transfer more load than Spur gear. That is the advantage of Spur gear. So vibrations will be very less. Here vibrations will be very high. Spur gear. Here the vibrations will be very less. But the problem is that slipping can occur here. Here chance of slipping is very less. Here chance of slipping is very high. Okay. The bevel gear is used to transmit power in inclined form. Okay, we need to transmit. This is used in automobile. Some differentials also it is used. It is used to transmit power in an angle. It's not assured that it's 90 degree, it can transmit power in an angle. Okay, ohm and ohm wheel is to power, transmit power in any direction. Okay, to transmit a ohm in a single ohm itself, we can arrange more and more ohm wheels. That is the advantage of ohm and ohm wheel. Okay, so this is these are the basic 4 different type of gears and its figures and its major differentiating factors. That is what I had talked with you about. Basically, you have to know that any gear, one will be the pinion, and any gear assembly, one will be the gear pinion and one will be the gear. Okay, so basic design knowledge, you have to know this, and the basic gear equation. What is the basic gear equation? The gear pair equation. I is equal to N1 by N2 is equal to D2 by D1 is equal to Z2 by Z1. Okay, if pinion is 1 and the gear is 2. This is the fundamental equation that you had already studied. And also one more thing, diameter is equal to module into Z. If it is D1, then it is Z1. It is D2, then it is Z2. Okay, these all things that you had studied in the previous semesters, mechanics and dynamics. You have studied these things. It's a single thing, no more complexity. So these relations are fundamental that you had already studied, and this is the new things that you have learned about the classification of gears based on gear teeth profile. Okay, so now onwards we are going to the design. So before going to the design, you have to make sure that you refer a standard text that mentioned in the textbook and understand the advantages and disadvantages of each gears. What are the advantages and disadvantages and application of Spur gear, advantages and disadvantages and application of helical gear, advantages and disadvantages of application of bevel gear and bomb gear. Everything, each and everything you have to study. That will be asking for theory questions for very minimum marks. And one more thing, you have to study law of gearing thoroughly. That is, you had already studied in the previous semester. For final year engineering student, he should know what is law of gearing. So you have to study with a neat diagram also what is law of gearing. It's a very important question for the university examination. So next, one more thing is that simply I will say one more: Spur gear, straight teeth; helical gear, inclined teeth; bevel gear, inclined power transmission; Worm and worm wheel can transmit power in any direction. Worm can accommodate multiple worm wheels. That is advantage of worm and worm wheel. Okay, so this is the basic. What is the advantages of helical gear over spur gear? It have a longer teeth, so it can withstand a longer load. It can transfer longer load. It have minimum vibration, but the chance of slip is here. So this way you have to study, comparing one with other. What is the advantage of this over that? Like that you have to study. Okay, so this is the basic things about here, and gears will be for type. You have to study the design of each of the gear mentioned above. So these gears, the problem will be asking for gear design. Most important that you have to know is that for this question, for Kerala University, no sub question will be there. 15 mark you will be get if you solve a design problem completely. No sub question will be asking. In my point of view, referring the previous question papers, I am suggesting that problem you will be getting maximum marks for 15. Okay, so you have to study the problem very well, and one question probably can ask for 15 mark of theory. 2 problem and 1 full question theory will be asking in my expectation, and you have to study the problem very well. And the problem, the main advantage of the problem of these 4 is that the skeleton system is same for every problem. Whatever problem you are doing, the skeleton system is same. So for the case of Spur Gear, every Spur Gear problem will be looking like similar, only the branches will be different. The stem will be same, the skeleton system will be same, the branches will be different. That you have to understand what is the change that you have to take, what is the thing that you have to accommodate here. That is the only thing that you have to think. Everything else, this module is the easiest module to score marks. The problem is that the problems are lengthy, but the way is same for every problem. Only some things will change on your way. That changes you have to understand. Everything else is easy. Okay, so design of spur gear is the first thing. So first thing, spur gear. We will talk about the design of spur gear. Okay, so in this video itself, we can talk about design of spur gear. Design of spur gear means how to design a spur gear. Okay, for a design, you need a handbook. We can do a design without using a handbook by hearting the equation, but it's very difficult since you are doing a lot of design problems. So that's why handbooks are developed. So use a handbook that of your choice. I am using a design data handbook by CBS Publications. And author is K. Mahadev. Okay, I am using this design data book for a demonstration for you, and I am using this data book for the design of spur gear first. Okay, let's go for the design of spur gear. So the design of spur gear, I am in the description of this video, a Google Drive link will be there. Open that link, that is my video Google Drive link. In that link there will be a file mentioning on design procedure of spur gear. Download that and keep it in your hand. Download that and keep it in your hand, and I will be talking based on that. Okay, design procedure. Design of spur gear. So design of spur gear based on a data book is the today's topic. Okay, so design of spur gear. So before starting the design of spur gear, you have to learn a problem. A question will be given, a problem will be given to you. You have to solve it. So take the problem and identify the case. Which case is that? So before starting the problem, you have to understand whether 2 things are given or not. Number of teeth and diameter. Okay, number of teeth and diameter of any gear is given or not. You have to check that. So number of teeth. Number of teeth is Z. Diameter of gear T. You have to check whether these 2 things are given or not. Okay, if they are based on these things, the procedure will be having a slight differences. Okay, so if the number of teeth is unknown in your problem, if number of teeth is given, take that. If number of teeth is unknown, always assume that. Without having number of teeth, we can't go forward. Okay, so if number of teeth is given, assume Z is equal to 20 for spur gear. It's an assumption, and we will find the actual number of teeth based on our design later. So if the number of teeth is unknown, Z is taken as 20. But if the diameter is unknown, the steps will be having some changes that we will deal with the coming cases. Okay, we will change the orientation of some equations. So before starting the problem, step 1, this consideration is taken, and go for the step 1. Step 1, material selection. Material selection. Select a suitable material for our gear. Refer the question. If the material is given, always choose that material. If the material is not given, we have to choose the material. You have to choose the material. Choose the material of your choice. You can choose any material of your choice mentioned in the table. So choose a suitable material of your choice. There is a hint that I have mentioned in that note in the description. The hint is that if the material is not given, take a material of your choice such that both the pinion and gear will be same material. Assume, write it like that, write it down like, assume both the pinion and gear are of same material. If both the pinion and gear are of same material, pinion always will be weaker. So we can assume that the design is based on pinion. Then the second step, we can see that second step. Step 2. Identify the weaker part. Identify the weaker part. To identify the weaker part, you have to calculate the strength factor. Strength factor is equal to sigma d into y. Okay, sigma d into y. So if the materials are same, you need not to calculate this, because we already know that pinion will be weaker. If the materials are different, so this is the pinion and this is the gear. Assume if this is the pinion and this is the gear, then both the pinion and gear are of same material. We are assuming if both the pinion and gear are of same material, always pinion will be the weaker one. The first thing will be breaking is pinion. If both are of different material, we can say we need to find in the step 2 which one is the weaker part. That if you will understand, we will do the problem. Okay, so y, we can find the y from page number 204. Y equation is there. Small y means Levi's form factor. Small y we can identify and find which one is the sigma d1. So find the sigma d1 y1 and the sigma d2 y2. Which of them is weaker? Design should be based on that. So now the step 3. Find the module. Find the module. Module can be found based on 2 equations. Both of the equations are mentioned in page number 204 of your data book. So for the case of that equation, 2 equations will be there, and the first equation, that is, if the equation Ft is there, the force is there, tangential force is there, then the question should be given with the diameter. That means, leave it. So to find the module, you have to know the diameter for using the first equation. Check whether what is the case. The diameter is known or unknown. If the diameter is known, take the first equation. If the diameter is known, take the second equation. For example, I will show you the page number. Take page number 204. Take page number 204. Equation 12.5b. We have 2 equations. M is equal to module is equal to. We have 2 equations. For the first equation, take the first equation if the diameter is known. Take the second equation if the diameter is unknown. Just that. If the diameter is known, take the first equation. If the diameter is unknown, take the second equation. Okay, just that. Okay, then after we can find the module from the 2 equations. Any of them choose based on our condition. Okay, and find the module. And after finding the module, you have to check whether that module is correct or not. Okay, for that you have to find out. You have to take the equation to 12.5a. Ft is equal to sigma d cv bym. Ft is equal to sigma d cv bym. Take that equation and find out the sigma d from that, design stress from that, and check whether it is lesser than the assumed one in the step 1. It should be less than the assumed one in the step 1. Then the design procedure that you have followed is correct. If that stress is higher, then the design is unsafe. write it down there. The design is unsafe. If the design is unsafe, you have to increase the module. If the module is 4, then increase the next step. From the standard table is there, the data book, take the standard table and increase the module. If the module is 5 here, then increase it to the next one from the table. Okay, so the module is increased, and after the module, the steps are repeated and the sigma d is found again, and check whether it is correct or not. The sigma d should be less than the assumed one. In the step 1, we should get a sigma d less than the assumed one. If it is less, then the design is safe. Step 3 is complete. Now go for step 4. Step 4, dynamic strength. For calculating the dynamic strength FD, we have an equation at page number 206. 207. We have an equation in the page number 207. Equation 12.12. Equation 12.12. Write down this equation and put the sufficient parts and find the FD. Simple. And next step 5, endurance strength. FEN. Calculate the FEN based on the equation just below that, 12.13a. Find FEN from that step and make sure that this FEN should be greater than FD. Therefore, design is safe. What is endurance? Endurance means cyclic loads acting on the gear. So the cyclic load, the endurance strength should be maximum of the dynamic strength. So this should be less than this. Then the design is safe. And also the last step, step 6, wear strength or wear load. FW, we can find that equation in the page number 208. FW is equal to D1 BQK. Write down that equation and find the FW. This FW also should be greater than FD. Then design is safe. Most of the case this will be safe. If it is unsafe, increase the value of sigma endurance. For this case, FW, if it is getting unsafe, there is no other go. Else we need to repeat from here. So avoid that. For exam point of view, just find out the suitable value of BH and Brenner hardness number and write it down. That's all. This is the step procedure for designing a spur gear. Just 6 steps, but it's very difficult. But it is not just simple as this. You have to write a lot of things, and you have to write a lot of equations and find a lot of small things from the data book, analyzing a lot of tables and equations. So the time that you have for time management, you have to complete this problem in 25 minutes. That is the maximum time that you can take for doing this problem. The average notebook, we need to take 3 to 4 pages to complete this problem. But it's very easy because every problem will have the same structure, only some things will differ. If you get that every problem is similar, that is advantage. Every problem won't be different. Each and every problem won't be different. You can find that every problem will be looking like similar, the structure is similar, but some things will change the entire thing. You have to understand what is that, where should that be applied. Everything else is easy. So what you have to do is understand the steps, read the attachment that I had given in the description, design of Spur Gear, that file, read it very carefully, and let's go do problem in the next video. If you have any problem in the language or anything, you can mention that in the comment box. If you want classes in Malayalam, then mention that also in the comment box. We shall do whatever thing. If you have any doubt or you have any feel that you anything felt that I had mistakenly said anything, you can mention in the comment box, or you can mail me the mail ID in the description. Okay.